Hi again, welcome back. Here we're going to look at perfect square quadratic equations. And the way to do that is we're going to use this square root property. A squared equals c implies that a is the square root of c or a is the opposite of the square root of c. These are two solutions to this a squared equals c problem. We use this when we have quadratic equations of a single variable where the b, if you remember the basic form, so this ax squared plus bx plus c equals 0. This is just the general form for a quadratic equation of a single variable. Here we have the a, the b, and the c are the coefficients. A is the coefficient of the x squared term, b is the coefficient of the x to the first term, and c is the constant term. Now, if we don't have this constant term, or this, if we don't have this linear term, the b, we have something of the form ax squared plus c equals 0. This requires either factoring or using this property. I think it might be easier to use this property to solve those. So if you look at all these, they're all going to be missing the bx term. Let's just take a look at the first one. So here we have 36x squared minus 400 equals 0. Notice there's no bx term. All right. We can take advantage of this perfect square property by moving this 400 to the other side. So we have 36x squared equals 400. All right, and now we have an algebraic expression equal to some number, and we can then take the, well, actually, let's divide by 36 first. All right, so we're going to have x squared equals 400 over 36. You could reduce that 400 over 36, but I'm going to leave it like that because I notice both 400 and 36 are perfect squares. So when we go ahead and do this, take the square root, we're going to, it's going to be a lot easier to do that. Okay. So now we have something squared equals a constant, it's 400 over 36. We can now use this property. So we know that x is either the principal square root of 400 over 36, or x is going to equal the opposite square root of 400 over 36. And just as a note, this is sometimes written as x equals plus or minus the square root of 400 over 36. I don't like to write it this way because this plus or minus stands for this thing right here with an or. Right? So this means exactly this. There are two solutions. Students sometimes see this plus or minus and think this is just one thing. No, it's two. Okay, now we should simplify this. We've got 400 squared of 400 is 20. Square root of 36 is 6. So we've got that, or negative 20 over 6, and that simplifies to 10/3, or negative 10/3. All right. Okay, let's look at the next example. So here we have x plus 1 squared minus 1 equals 15. And we'd like to get the algebraic expression squared equal to the constant, right, in this case. So we'll just add the 1. So x plus 1 squared equals 16. Right, and now we have exactly this situation. We have an algebraic expression squared equal to c. Algebraic expression, x plus 1 squared equal to some number. All right, so we take the square root both sides using this property. So that means x plus 1 equals the square root of 16, or x plus 1 equals opposite the square root of 16. Of course, the square root of 16 is 4. So we have x plus 1 equals 4, or x plus 1 equals negative 4. That gives x equals 3, or x equals negative 5. All right, last one. This is very similar. So if you'd like to, go ahead and pause the video and work it just like this one. Okay, let's subtract the 144. So we have 11y minus 7 squared is negative 144. And, sorry, did not mean to trick you, but here we have a square equal to a negative number, and we know that if we go ahead and apply the square root, we've got the square root of negative 144, or 11y minus 7 equals the opposite of the square root of negative 144. That's not a problem really, because we know that if we take the square root of a negative number, we're dealing with a complex number. So if you notice that this should be, 12i. So 11y minus 7 equals 12i, or 11y minus 7 equals negative 12i. All right, so we add the 7, so 11y equals 7 plus 12i. We can go ahead and finish that by dividing by 11. So I'm going to write it as 7 divided by 11 plus 12 over 11i. Right, and this also. 7 minus 12i. Y equals 7 over 11 minus 12 over 11i. Right, and the reason I write it this way is because when we have a complex number, we always want to write it as a plus bi. So 7 over 11 plus 12 over 11i. If you wrote 7 plus 12i all divided by 11, that's right, that's the right answer, but it's not in the correct form. So we'd always want to write our complex numbers in a plus bi form. Okay. Next up, we're going to look at the quadratic formula to solve more general quadratics that are of the form ax squared plus bx plus c equals 0. That's a technique that will always work. So stay tuned for that.